Hello everyone, welcome to today's class, and in this class we'll be discussing a very important aspect when it comes to chemistry. Now this topic is an interesting topic, but a lot of students get confused about it due to the way they were being taught either in their Sunday school by their teachers or by their tutorial tutors, right? And that is why in this video I will make sure I trip down this topic, because this topic is very important whether you are preparing for your JAMB, whether you are preparing for your WAEC, whether you're preparing for your NECO, even your post-TME, any external exam, and even your internal school examination. This concept known as empirical formula is very important, because you must always be able to give the whole ratio of element combination in a compound, and that is why I decided to treat this topic today. And if you are just coming across my channel for the first time, my name is Basi Ejoba. I'm a student in the University of Calabar studying medical and basic science, and in my channel I help students level up their academic game. I also share helpful tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so I can continue getting updates anytime I will drop videos like this, and so that you can help me grow. And just like I've said, in this video I'm going to show you how you can be able to solve empirical formula. But the first big question we are supposed to ask ourselves is this: what is empirical formula, and how does it relate to my life as a chemistry student? Now when we talk about empirical formula, let me write down the definition. Empirical formula of a compound is its simplest formula. So you say the empirical formula. So I'm going to be writing it down. Please make sure you take out your book and pen and jot down everything I'll be dropping in this video. So don't just watch it as a video sake, but make sure you follow up step by step. So you say the empirical formula of a compound. You say the empirical formula of a compound. The empirical formula of a compound is its simplest formula. Is its simplest formula. Please follow up. Is it simplest formula. And it doesn't just end there. It tells us the ratio in which these elements are combined together. It tells us ratio. Let me take out my marker again. Let me change this marker. So it tells us the ratio. Let me see. It tells us the ratio. It tells us the ratio in which these elements are combined together. It tells us the ratio in which these elements are combined together. Please follow up. Are combined together, right? That means if we are to have a particular compound, my marker is giving me issues. So if we are to have a particular compound, let's say sodium chloride, right? Let's say sodium chloride. This is a compound. What empirical formula is simply telling us about is that this is a compound, right? And this compound is made of element? Because we say a compound is a combination of two or more elements, right? So now the empirical formula is simply telling us the ratio in which these elements are combined together. And in this particular instance, which we are talking about sodium chloride, it is simply 1:1. That is the ratio of the combination in sodium chloride. So that is what empirical formula is trying to tell us about. So right now we'll be moving to steps to calculating empirical formula. What are the steps to follow? So make sure you jot down these steps to follow. The moment you get down these steps, there is nothing you cannot solve when it comes to empirical formula. But now we will not just limit ourselves to empirical formula. We will also be solving the molecular formula. So in case you are asked to solve empirical formula, and from the empirical formula you are made to also deduce the molecular formula, don't worry. This question is mostly common when it comes to WAEC and JAMB. Don't worry, I will show you on how you can be able to get it as A, B, C. So we say steps to calculate empirical formula. So it says steps to calculate as a subtopic. Say steps to calculate. Steps to calculate, right? So you say steps to calculate empirical formula. So the first step is that you write down the mass or the percentage composition of each of the elements that is involved in that compound, that is in that compound. So it says you write down the mass, you write down the mass or what percentage what composition. Write down the mass or the what percentage what composition of each what element, of each element. Write down the mass or the what percentage what composition of each what element, right? So that is just how what it is. That is for number one. Number two is that you divide by their what atomic what masses. So you say divide by atomic what masses, divide by the atomic what mass, which is the what relative atomic what mass. So you say ROMA, right? So you say the relative atomic what mass. I don't know why my marker is not giving me what I want. I just pray you are able to see what I am writing on the board. So you say number three, divide all answers by the smallest value. So number three, we say number three, divide all answers by the smallest what value. So you say number three, divide all answers divide all answers by the smallest value. Divide all answers by the smallest value. And number four is that you write down the ratio as the empirical formula. So you say number four, you write down the ratio, write down the ratio as the empirical formula. Write down the ratio as the empirical formula. Write down the ratio as the empirical formula. Please click on the red subscribe button, subscribe to my YouTube channel to encourage me. If you love what I am doing, please subscribe to my channel to motivate me, to make me to continue dropping helpful videos like this. So this is just it. You say this is the four steps in calculating what empirical formula. The first one is that you write down the masses or the percentage composition of what each of these what element. This mass or the percentage composition will be given to you in the question, right? So it will be given to you in the what question. Now we didn't just say of elements or compounds, say of each of these what element that make up this what compound. That means each of these element that makes up this compound, their percentage composition will be what given, or their what mass will be what given, right? So now number two, you divide each of these elements, right? You divide each of these elements mass or percentage composition by their relative atomic what mass. You understand? Each of these elements divide their what their mass that was given with their relative atomic what mass. Then number three is that after you divide each of these what elements, you are going to get what different what values, right? So some you are going to get like let's say 10 divided by 2, you are going to get like 5, you are going to get like 2, you are going to get like 1. So if you check out, if you have like 10 5 2 or 1 or 10 5 2, you find out that the smallest value there is what 2. So you are going to divide the 10 by 2, divide the 5 by 2, and divide the 2 by what 2, right? So that is just, you divide all the answers by the smallest value. Then number four is that you write down the ratio as the what empirical formula. So without much further ado, we are going to be solving right away. So we are going to be following each of these rules because I'm going to be cleaning it. I already have it here in my book. I'm going to be following it step by step. So that is just how it is. So let's get the first question that was given to us, or that is being presented to us here, right? So we say example what 1. It says a compound contains 12 grams of what carbon. So we say example 1. Example what 1. A compound contains 12 grams of what carbon, right? It says a compound contains a compound contains 12 grams of what carbon. A compound contains 12 grams of what carbon. A compound contains 12 grams of what carbon. A compound contains 12 grams of carbon and 2 grams of what hydrogen, and 2 grams of what hydrogen. A compound contains 12 grams of carbon and 2 grams of what hydrogen. Find the empirical formula. Find the empirical formula. Find the empirical what formula. Right, so that is just how it is. Find the what empirical what formula where you are being given the relative atomic mass. So we say ROAM. We say ROAM, right? The relative atomic mass of carbon is what 12, and the relative atomic mass of hydrogen is just what 1. So we say carbon 12, hydrogen what 1, right? So that is just how it is. The next thing we just do here, we say what solution, right? Make sure you follow up everything I am saying in this video. So this is just, it says a compound contains 12 grams of what carbon and 2 grams of what hydrogen. find the empirical what formula, where you are being given the what relative atomic mass of carbon to be 12 and the relative atomic mass of hydrogen to be what 1. This is as simple as what ABC. The first thing you simply do is to write down the what mass. At this point, we are not being given the what percentage composition, because what we are being given here is what grams. So the grams is the what mass. So what you simply do, you say carbon. So in this place, carbon, 12 grams of what carbon. So say the mass of carbon here is what 12. So say mass of carbon. So let me divide this board into 2. So I'm going to copy here, I'm going to write here, I'm going to also write here. We say mass of carbon, we say mass of carbon is equal to what 12 what gram. And we say mass of hydrogen. So we say mass of hydrogen, mass of what hydrogen. Yeah, mass of hydrogen equals to what 2 what gram, right? So this is just how it is. This is the first step that we have gotten, right? So now the second step is this. So we say step 2, right? So we say step what 2. This is our step 1. Step 1. So we say now step 2, what we simply have to do is to divide each of these mass that has been given with their relative atomic what mass. So we have the mass of carbon here to be what 12. So the relative atomic mass of carbon that's been given here is what 12, right? So what we simply do is to say, okay, carbon, right? So we say carbon, right? We say carbon 12 divided by the relative atomic mass, which is what 12, and we say hydrogen. Hydrogen here that was given is what 2, right? So hydrogen divided by this relative atomic mass to be what? Let me space this down. Let me space this. So say hydrogen is what 2 divided by its relative atomic mass, which is what 1, right? So now this is carbon, which is what 12, which is the mass that was given, and the relative atomic mass to be what 12, and hydrogen, which is what 2 divided by what relative atomic mass, which is what 1. So now getting this here, that means we are going to be what dividing, right? So now 12 divided by 12 is what 1, right? 12 divided by 12 is going to be what 1. So our carbon here has been divided to be what 1. Now hydrogen, 2 divided by 1 is what 2, right? 2 divided by 1 is what 2. So now this is the division that has been what gotten. So from here we'll move on to step 3, right? We'll move on to what step 3. And step 3 states that you divide each of this value by the smallest what value, right? So you divide each of this that has been given with the what smallest what value. And in this case, the smallest value we have here is going to be what carbon, which is what 1, right? The 12 divided by 12, which is what 1, because it's smaller than what hydrogen, which is what 2. So what we simply have here is going to be 1 divided by what 1, right? So we say yes, we say 1 divided by what 1, and we say what 2 divided by what 1, right? Because we are going to be using the 1 to divide each of these what value. So now 1 divided by 1, right? So that is what we'll be having, right? So say 1 divided by 1 is still equals to what 1. 1 divided by 1 is what 1, and we have our 2 divided by 1, right? 2 divided by 1 is still what 2, right? So that is just what how what it is. That is for our what, step 3. Then the step 4, right? The step 4 is simply for to write down this number as a what a whole ratio, right? Is to bring down, is to write the ratio as a what empirical or formula. So what we simply have here is our carbon to be what 1 and our hydrogen to be what 2, right? So the empirical formula of what we'll be having here is what our what CH2, right? So that is just how what it is, right? That is just how what. So you say this is our empirical what formula, empirical or formula. So it's what CH2. Now this is just how to follow it when it comes to solving of what empirical or formula. It is not something that you're supposed to be afraid of. Just follow up each of these what rules, right, that I have listed out in this particular what video, right? So we'll be moving ahead to be solving example number what 2. And this example number 2 that we will be solving, we will also be adding what is known as the what relative what molecular what mass, right? So we'll be solving for the what molecular what molecular what formula of each of these what compound. We are not just going to be looking at the empirical formula, but we also be looking at the what molecular. Our example number 2, right? So that means you have gotten every steps to follow. So but this example number 2, like I said, we'll be solving for the what molecular what formula, right? It's still the same thing, because you first get the what empirical formula, and after getting the empirical formula, that is when you move ahead to solve for the what molecular what formula. And also I will be giving you assignment at the end of this word class. So I'll be dropping an assignment at the end of this word class, right, where you have to what solve. But in case I don't have an assignment to give in this particular video, I'm going to make sure in the comment section I'll be dropping an equation for you to what answer, and make sure you drop it in the comment section as the answer, in the comment section as a what reply. So we say example number 2, That is question number 2, right? It says find the empirical formula of a compound which on analysis, it says find the empirical formula, find the what empirical formula of a compound find the empirical formula of a compound which on analysis find the empirical formula of a compound which on analysis yields the following as a reacting what mass. Yields the following as a what reacting what mass. Yields the following as the what use the following as the what reacting what mass, right? So use the following as the what reacting what masses. Sorry, use the following as the reacting what masses. So we have our carbon here. So we say carbon. Our carbon here is what 2.0 gram. So we have our carbon here to be 2.0 gram. We have our hydrogen to be 0.34 gram. So we have hydrogen to be what 0.34 gram, and we have our oxygen to be 2.67 gram. So we say oxygen equals to what 2.67 what gram. Now the question is, from your result find the molecular formula of the what compound. It says from your what result find the molecular formula of the what compound. Find the molecular formula. From your result find the molecular formula. From the result find the molecular formula of the compound from your result find the molecular formula of the compound if its relative molecular mass is what 60. So we say if it's ROMM, if it's what relative molecular mass is what 60, right? So we are being given the atomic masses of each of this what element that makes up this what compound. So we say carbon equals to what 12, hydrogen is what 1, and we already know that oxygen is what 16. Right, so we say oxygen equals to what 16. So now this is the question that has been given. It says find the empirical formula of a compound which on analysis sees the following as they were reacting what masses, right? Carbon 2.0 gram, hydrogen 0.34 gram, oxygen 2.67 gram. And now from your result find the molecular formula. So at this particular point we are not just looking at the empirical formula, but we are also looking at the molecular formula. I'm going to show you how you can be able to get it. So with this one now, this is going to be my calculator. This is where I'm going to be solving, because right now we are going to be solving, right? So what we simply do is I'm going to clean this down. I already believe that you have the questions in your book, right? So we are going to clean this so that we can be able to solve, right? So we are going to be cleaning this so that we can be able to solve and divide the board into 2. So we are going to be dividing this board into 2, and we say solution here, right? So we say solution. So the first thing you simply have to do is to write down each of the reacting masses, right? So we say carbon. So we say our carbon equals to 2.0 gram. So our carbon to be 2.0 gram. Our hydrogen to be 0.34 gram. Our hydrogen to be 0.34 gram. Our oxygen equals to 2.67 gram. Right, so this is the first step to follow. Now, after getting the first step, what we simply have to do is to divide each of these reacting masses by the relative atomic mass of each of these elements. So we say step 2. Right, I'm just writing this step 2 so you can be able to follow. It's not necessary in the course of you solving you should to be writing step 2, because the person setting the question already know what you're expected to do. But I'm just putting this for the purpose of learning. So we say step 2, which is dividing each of these elements by their relative atomic masses. So we say for carbon, so we have our carbon here. So for carbon, what we have here for carbon is 2.0, right? 2.0, and we already know that the relative atomic mass of carbon is carbon 12, right? So we have for hydrogen, so we say hydrogen, we have our 0.34, and we already know that the relative atomic mass of hydrogen is 1. And we have for oxygen, so we say oxygen, what we have here is our 2.67 gram divided by the relative atomic mass of oxygen to be 16, right? So that is just how it is. So now what you do is you take your calculator and see how you can be able to punch it and get your correct answer. So we are going to be dividing, right? Because we are expected to divide. So we are going to say 2.0 divided by 12. 2.0 divided by 12 is going to give us 0.1666666. So what we simply do is to approximate. So we are going to say 0.167, right? 0.167. So we'll move on to the next one, and we say our 0.34, right, divided by what? 1. That is for hydrogen. 0.34 divided by 1 is still going to be what? 0.314. I hope you follow and see how I'm writing it because of space. Then we have our oxygen, right? So we say our 2.67 divided by what? 16. Right, so 2.67 divided by 16 is 0.166875. So we are just going to approximate and say we are going to be approximating and say it, and say the answer is going to be 0.167, right? So that is just how what it is, right? So now we move ahead. We divide each of this value by the what smallest what value, right? We are going to divide each of these value by the smallest what value. So what we are simply going to do is we are going to start with the first one here. So we are going to say 0.167. So the smallest value here, if you check, is going to be 0.167. So it says 0.167 divided by what? 0.167, right? So we have 0.34. So we are going to say 0.34 divided by what? 0.167. And we are also going to say 0.167 divided by what? 0.167. These are not just numbers that I am formulating. We are getting it from this what answer, which is dividing all by the what smallest what value. So now what we have here is 0.167 divided by what? 0.16 divided by 0.167. So what we are going to be having here is just what? 1, right? 0.167 divided by 0.167 is what? 1, right? So we have our second one, which is 0.34 divided by 0.167. So what we have here is 2.0. So this is just what? 2, right? And we have our 0.167 divided by 0.167 is still going to give us what? 1. This is step 3. Then the ultimate step 4, which is you representing it in the what? Empirical formula, right? Yes, representing it in the empirical formula. So what you simply do is to bring out each of these for compound, right? So we say C, which is for carbon, is what? 1, right? And we have our hydrogen here to be what? We have our hydrogen to be what? 2, right? So we say CH2, and we have our oxygen to be what? 0, right? So what we have here is CH2O, CH2O, and this means that this compound were represented in a ratio of what? 1:2 is to what? 1, right? 1:2 is to what? 1. That is just how we can be able to get what? Empirical what? Formula. But the truth of the matter is that we are not yet done, because the question says from your results CH2O, right, find the molecular formula. From your result, find the molecular formula. So for now, we have gotten our empirical formula to be what? CH2O. Write it down. Write it down. So this is our empirical formula. This is our empirical formula. So this is our empirical formula. Write this down. So this is the what answer that's been given for the empirical formula. But let's move on to solve for the what molecular formula. Solving for the molecular formula is something that is very, very what easy. So you don't even need to what panic, right? So to solve for the molecular formula, what you simply have to do is to bring in an unknown, which is what? X. So we are going to be bringing in an unknown. So let me just clean all of this, and we'll be bringing in that Mr. Unknown, which is what? X, right? So say to find or to solve. So let's write. To solve for molecular formula. To solve for molecular formula, right? To solve for molecular formula, what we simply have to do, right? To solve for the molecular formula, knowing fully well that we have been given the molecular mass, right? So what we simply have to do is to bring in this our compound that has been given here, right? So we say open bracket, we say CH2O, right, X equals to what? 60, because the relative molecular mass that was given to us here is what? 60. So if in case you are solving the equation and you are being given 12, 19, 20, it all depends. So you just have to substitute. But for this question, what we have here is what 60. Now, what this means is that this is the compound and this is the what unknown equals to what 60. Right? What this simply means is that this here is going to be what, since there's a bracket here, and this bracket means for multiplication, that means this unknown that is outside the bracket is going to be what, multiplying with each of this what element, or is going to be multiplying with the compound, right, that is in here. So let's see how we are going to get it. But before we get this, right, before we solve for this, what we are going to be doing is that we are going to get the molecular mass of CH2O. We are going to be getting the what, relative molecular mass of what, CH2O. To get the relative molecular mass, what we simply have to do is to bring the atomic mass of what, each of these what elements. So we already know that the atomic mass of carbon is what, 12. So we say 12, right? We are going to say 12 plus, right? We are going to say 12 plus. We know that the relative atomic mass of hydrogen is what, 1, but they say 2 here, so we are going to say 1, right, plus what, oxygen, which is what, 16, right? And this is what our x equals to what, 60, right? So that is just how what it is. So we are going to say 12 plus what, 2 times 1 is what, 2, plus what, 16, all bracket will close, x equals to what, 60, right? So what we are simply going to do is to see how we are going to what, add, right? So we say 12 plus 2 plus what, 16. 12 plus 2 plus 16 is going to give us what, 30, right? So this is our what, 30 x, right, equals to what, 60, right? So that is just how what it is, but we are not yet what, done, right? Because we are moving one step at a what time. So now when we get this is 30 bracket open, 30 bracket close, x equals to what, 60. What this simply means is that we are going to be timesing, we are going to times this 30 with this what, x. So 30 times x is what, 30 what, x, right? 30 times x is going to give us what, 30x equals to what, 60. Now what we are looking for is the what, molecular what, formula, and we have our what, x to be what, the unknown. So what you do is you divide both sides by the what, coefficient, right? So this is simple equation. We have moved on from chemistry, now we are currently in mathematics simple equation, but it's still related. So to solve for this is that we divide both sides by what, 30. So we are going to be dividing both sides by what, 30. So what we simply say is 30 divided by 30, and 60 divided by what, 30. So 30 is going to cancel itself, giving us what, 1 times x is what, x. Alright, so we say x equals to 60 divided by 2 is going to give us what, 60 divided by 30 is going to give us what, 2, right? So that is just what it. So the molecular formula, now pay attention what we are going to do here. The molecular formula, so this is what, 2, right? So what is this? What this is going to be is something like this, CH2O, right? 2, right? Because of the x, the 2 here is the what, x that was what, unknown. So we are going to use this 2 here to times everything that is in this bracket. Remember when I said it? So 2 times c is going to be what, C2. So we are going to have what, H what, 4, and we are going to have what, O what, 2, right? So this is the what, molecular what, formula. This is the what, molecular what, formula, which was gotten because through the what do you call it? Which was gotten through the what, empirical what, formula. Now this is our what, molecular what, formula. This is our what, molecular what, formula. This is our molecular what, formula. And I think this can also be expanded to give us our CH3COO what, H, right? So this can also be expanded to give us what, this. So this is just how you can be able to solve for what, empirical formula and molecular what, formula, right? So that is just what, how what it is, right? So we also have the third problem here to solve, which is using the word empirical, when you are going to be solving using the percentage or composition. So I'm going to be dropping this as an assignment. Yes, I'm going to be dropping this as an assignment. So I'm going to be dropping it in the comment section. No, let me not drop it in the comment section. Let me write it for you, right? So let me write it. Or what if I drop it in the comment section? No, let me write it because I might not be able to type it well in the comment section. So we said example number 3 says determine the empirical formula. So it says example number 3, which you are going to do for me. It says determine the empirical formula of an oxide. Say determine the empirical formula. Determine the empirical formula Determine the empirical formula of an oxide. Determine the empirical formula of an oxide of what? Nitrogen. Determine the empirical formula of an oxide of nitrogen containing 70% oxygen. Containing 70% what? Oxygen. If the relative containing 70% what? Oxygen. If the relative molecular mass of the oxide, if the what? Relative molecular mass, if the relative molecular mass of the oxide is 92, find the what? Find the molecular formula. Find the molecular what? Formula. Right? So that is just how what it is. That is just how what it is. This is very, very simple because this from this 70%, you already know that percentage is what? 100. And we already said determine the empirical formula of an oxide of nitrogen. That means there are two elements here, oxygen and what? Nitrogen. And we already say oxygen contains what? 70 what percent. That means you already know the one that is supposed to contain what? The remaining percentage that will make it what? 100. So it is very, very easy to solve what? This, right? So that is just how it is when it comes to what? Empirical formula, or when it also comes to what? Molecular what? Formula. Now, if you need us to go in depth, if you want to register for my class, it's as easy as ABC. Check the description. You are going to see my WhatsApp number 07062462746. Chat me up on WhatsApp and you get to register in our class. If you are preparing to write your JAMB UTME for 2026 and you want to score up to 320 and above, I believe my tutorial is the perfect place for you. If you are preparing for any external examination, or if you want to also get the knowledge, feel free to also chat me up and register for our class. Registering for our class will help you get access to timely responses from our tutors. You will also get materials that will help you, and you will be getting updated past questions and answers and materials which will really help you in the course of your study. I will be following you up personally one-on-one until the day you will write your JAMB UTME for 2026, or whatever you'll be writing as of the time you'll be watching this video. Register for our class, and that will be one of the smartest investments you have made so far. If you love this video and you wish to continue getting videos like this, please don't forget to hit on the red subscribe button, and also share these videos to your friends so they can come here and get value. And in turn, I will feel motivated to continue dropping videos like this. Until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.